let us start the next question, which is example number 5, that I need to prove that 1 plus x raised to power n is greater than or equal to 1 plus nx. Okay, and where n belongs to natural numbers and x is greater than minus 1. That means x greater than minus 1 means 1 plus x is greater than 0, right? So 1 plus x is something positive. It cannot be 0, it is always greater than 0. Alright, let us start. So assume this to be Pn, right? Let us say this statement is Pn. Okay, that, and we need to prove this statement. 1 plus x raised to power n greater than equal 1 plus nx. Okay, so first thing is n equal to 1. We need to prove p of 1 to be true, right? So p of 1 is 1 plus x raised to power 1 greater than or equal to 1 plus, I'll replace this n with 1, so 1 plus x. So if you see 1 plus x is greater than or equal 1 plus x, so it is true. So I can say p of 1 is true. If you are confused that these are two equal things, how can I write greater than or equal to? So yeah, I can write it because 3 is greater than or equal to 3. It is okay, right? Because this is greater than or equal to 3. So this is a correct statement, or this is a valid statement. This is also a valid statement. All right, number 1, that p of 1 is true. Now assume p of k is true. That will give me 1 plus x raised to power k is greater than or equal to 1 plus kx, and let it be my equation number 1. Now based on this equation number 1, I'll show p of k plus 1 to be true. Now I will not tell you what, okay, let me tell you, as this is the first question of this lecture, so let me tell you what I am looking for. I am looking for 1 plus x raised to power k plus 1 to be greater than or equal to 1 plus k plus 1 into x. So I want k plus 1 at every place of this k, right? I want to replace k, or I want this statement to be true for k plus 1, or this result is what I am looking for. And I need to use this statement only to do that. So now let us use the left side of this inequality. 1 plus x raised to power k, or you see this is an inequality, right? So I can very well multiply both sides of this inequality by something positive. And in the beginning of the lecture, I told you that x is given as greater than minus 1. So that means 1 plus x is something positive. And I can multiply both sides of an inequality by something positive without changing the inequality. So I can write this by multiplying both sides of this inequality by 1 plus x. I can write this. If you are confused, you can check this. If 5 is greater than 3, if I multiply both sides by 2, 10 will be greater than 6. Right? So I can multiply both sides by something positive. But if I multiply both sides by negative, let us say I multiply both sides by minus 2, then minus 10 would have been lesser than minus 6. Right? This inequality would have changed if I multiply both sides by something negative. But now I have multiplied something by something positive, so this inequality will remain as it is. So I multiplied by 1 plus x, which is positive as per the question. So I can do that. I can multiply it on both sides. Now look at this. The left hand side is 1 plus x raised to power k plus 1, and here it is greater than or equal to, let us multiply it inside, 1 plus kx plus x plus kx squared. Okay, and if you notice only this portion, this is 1 plus k plus 1 x, right? So this is what I require. I don't need this. So how do I eliminate this? Now you know, if I say 6 is greater than 4 plus 1. Okay, so this is something positive. Can I also say that 6 is greater than 4? Yes. So I can very well take it away without disturbing the inequality. But if, let us say, I say 6 is greater than 7 minus 2, I cannot, take it away and write 6 is greater than 7, right? But if, now see, k of x squared, now k is a positive integer and x squared is also something positive. So this, even if x is 0, or it is given that x is greater than minus 1, okay, so even if x is 0, this is always greater than or equal to 0, right? So if this is greater than or equal to this entire expression, it will be definitely greater than or equal to this expression, that is without this. I can lose this without disturbing the inequality. Okay, if you don't understand it, you can try with simple numbers here, right? That if, let us say, I am given a number 9 and it is greater than or equal to, let us say, 7 plus 2, then 9 will be greater than or equal to 7 also, right? I can remove this. But if it is something negative, I cannot do that, right? And this is also I have shown here. And this is p of k plus 1. So p of 1 is true, and if p of k is true, then p of k plus 1 is true. This implies, by principle of mathematical induction, p of n is true for all n belonging to natural numbers. Okay, this is the statement that you need to write in the end of the question. Now we need to prove that this is divisible by 24. So let it be my statement Pn. What is Pn? That this is divisible by 24. 2 into 7 raised to power n plus 3 into 5 raised to power n minus 5 is divisible by 24. So for n equal to 1, p of 1 will be 2 into 7 raised to power 1, so 2 into 7, plus 3 into 5 raised to power 1 minus 5. And what will be this? 7 into 2, 14, 3 into 5, 15, 14 plus 15 is 29, 29 minus 5 is 24. So it is divisible by 24, which is 24. So 24 is divisible by 24. Hence I can say p of 1 is a true statement. So I have checked, or I have verified, that the statement p of n is true for n equal to 1. Now I'll assume it to be true for n equal to k. So assume p of k to be true. That means 2 into 7 raised to power k plus 3 into 5 raised to power k minus 5 is divisible by 24, or in other words is a multiple of 24. So I can write it as 24 into something m, where m belongs to natural numbers, right? Because it is a multiple of 24. Now let us look at it. I need to prove now, to show that p of k plus 1 is true, right? So I will require 2 into 7 raised to power k plus 1 plus 3 into 5 raised to power k plus 1 minus 5. I need to show that this expression is also a multiple of 24, and I will use this equation to show that. Okay. Now I'll just need to do some manipulations. 7 raised to power k plus 1 can be written as 7 into 7 raised to power k. So 7 into 2 will be 14, and into 7 raised to power k. What I've done here is, this was 2 into 7 raised to power k plus 1. So I've written is that 2 into 7 raised to power k. Then plus, this is 5 into 5 raised to power k. So 5 into 3 is 15. So 15 into 5 raised to power k. Something similar to this. Minus 5. Okay. I want to use this equality here, right? So what do I do with this expression to be able to use this equation? That is the manipulation that I want to do here. See, one of the things that you can do is you can replace this 7 raised to power k. You can take everything else on the right hand side and find the value of 7 raised to power k in terms of this 24m and replace it here. Other thing, you can bring this expression in form of this expression. Now if you see, 2 into 7 raised to power k plus 3 into 5 raised to power k, and here I have got 14 7 raised to power k. So if I have got 21 5 raised to power k, I will be able to use this portion. Then what I am saying is, if I write this statement as 14 7 raised to power k plus 21 5 raised to power k, if I write it as 21 and but I have got only 15, so what I'll do is I'll subtract 6 into 5 raised to power k and then minus 5. Okay, now if you see this, if I take 7 outside, it will become exactly this statement, this portion, right? So I leave this manipulation part to you, how you think about it. I am doing like this, you can take some other route and we will reach at the same conclusion in the end. So this is, if you only look at this encircled portion, this will be 24m plus 5, right? I can take this 5 on the right hand side. So what I'll do here is I'll take 7 outside and write 24m plus 5 here. Okay, and then I'll have 6 into 5 raised to power k minus 5 here. Now let us see what do we have. So this is equal to 7 into 24m plus 7 into 5, that is 35, and minus 5. So 35 minus 5 minus 6 into 5 raised to power k. If you notice, I don't have to do any manipulation with this part because this is already a multiple of 24. This is 30, right? This is 30. So let me write it as 30 minus 6 into 5 raised to power k, or if you notice, I'll need some more space here, so give me a moment. Okay, so I have to write that portion once again because that may have gone somewhere down. So 7 into 5 is 35, and then this minus 5 is there, minus 6 into 5 raised to power k. This is a multiple of 24, so I don't have to disturb this and let it be like this. This is 30, this is 6 into 5 raised to power k. So if I take 6 as common, this will be 5 minus 5 raised to power k. Now see, this expression has got two terms, one of which is divisible by 24. I just need to show that this term is divisible by 24, or this is 6 into something, so I just have to show that this portion 5 minus 5 raised to power k is divisible by 4, right? And to do that, I can again use induction. 5 minus 5 raised to power k is divisible by 4. What I can do is I can consider p of 1, that 5 minus 5, which is 0, so it is divisible by 4, so p of 1 is true. Now consider that 5 minus, now consider p of k to be true, so it will be 5 minus 5 raised to power k equal to some 4q, let us say. Now I just need to show p of k plus 1 to be true. So for that, let me do this. So which is 5 minus 5 into 5 raised to power k, and from here I can replace this 5 raised to power k. So what is 5 raised to power k? 5 minus 4q. So 5 minus 5 minus 4q here, and then this is nothing but 5 minus 25 plus 20q, and if you notice, this is nothing but 20 can be taken outside, and q minus 1. So it is divisible by 4. So I can say that this statement is true, right? So in this expression you can replace this by something multiple of 4. So I can say this part is divisible by 24, this part is divisible by 24, hence this entire expression is divisible by 24. Hence in the above question here, p of k plus 1 is true when p of k is true. Okay, I hope you understand what I am trying to say. Let me write it for you. What I am saying is, this I have proved to be a multiple of 4, so let it be 4q. So this term, if I write it as 7 into 24m, this term I can write it as 6 into 4q. Now if you see, 24 can be taken outside and inside I'll have 7m plus q, right? So this is divisible by 24. And what was this? What was this? This was p of k plus 1. So I can say, if or when p of k is true, that will imply that p of k plus 1 is true. Hence my p of n is true. And what was p of n? What was p of n? This statement. This is true. So I proved that 2 into 7 raised to power n plus 3 into 5 raised to power n minus 5 is divisible by 24. Okay.